Hello developers, let's start developing. So it's that time finally that we're gonna take on task 7. I took already a look at task 11 and it looks very fun to solve, so I will try to have that up today as well. So that means that today is the 7-11 day, but that we're gonna take on tasks 7 and 11. And so far, I think those two tasks have the best description so far, since we want to update a device and we are issuing this command, pretty please with sugar on top, but the device says we have no space left. So we want to analyze the file system and see what we can and what we should delete, so to say. So we have some commands together with output. Basically, we have a snapshot on the of the console, something like this, and it's not separated what is actually a command, what is actually a response. We will need to take care of that ourselves. So first of all, the input parsing will be quite a fun part of this. So we have three different commands that we are using. One is go to a specific folder, and from what I've seen, both in the test input and in the demo input, we only have that at the very top of our screen, at the very top of our input. So after that, we are moving around our file system, but both the example and the real input start with go to the root. So that means that we can kind of, let's say, ignore even the first line of the input, since it just gives us it says go to the root. So that is what I will do. Of course, this only works for this specific kind of input. Otherwise, I would have some condition that indeed the first line is that. Actually, let's do that. Why not? Lines equals, yep. Um, yeah, the root line should be equal to, is not equal to this. Then we can, yes, this won't happen ever, but if it happens, then we're gonna throw an error and say that our input, our invariant was broken. We expect this to be the condition of the input. If the input is not like we expect it to be, we're gonna throw an error because we don't know what else to do. So, yeah, I like this suggestion from Copilot. It says, create a folder like this. But the thing is that we don't have a class called folder or an interface or a type or something like that. And I was thinking that for this problem, I would actually like to do something exactly like this. And that's about it. I would want to have not an interface, but a class. And moreover, I'm going to create another class that's going to be the parent. So we're going to have a class that's going to be called FS item, file structure item. I don't have a better thing to do to call this, but it will be an abstract one. And it will have a name of or a string, and it will have a size method that returns a number. And that one's gonna be abstract. Yeah, so I have an abstract class that depicts any kind of file system item. And I will have classes that say, well, this class is extends fs item, and then we don't need this. And we're gonna need to have a size method. Let's have it like this at the moment. Let's have another class. Yep, we already have a name. Actually, we can have something like this here. Yeah, let's have a private number, and actually I'm gonna add a constructor that says, yeah, do whatever you want to do, what you think, and size basically returns the underscore size, and that is gonna be our file class, which means that right now we can implement the size class of our folder. The size of a folder is, well, it's the sum of the sizes of its children. Yeah, I take a selector here, and this means that we're gonna need sum for child over child. For a child, give me child dot size. And the children are not folders, the children are file system items. And I can add this, for example, because all the folders have a parent except the root folder that doesn't have a parent. And we can initialize this on an empty array. And maybe we will add a constructor later on if we want to, but no real need. Let's try if this works. Yeah, this is nice, because now the size is not a method, it's a property. I love properties because they look simpler. Sometimes they will hide quite a bit of code, but it still means that we want to call it like it's a regular number. And of course, we can have all kinds of pre-calculations and whatnots, and we can have methods like child or whatnot, but for now, looks okay. So basically, we can define our root, and that's gonna be our, you know what I'm gonna do? I'm gonna do something else. I'm gonna add another level of indirection here, because you with when you're modeling stuff, you can always model more stuff. I'm gonna design a class that's gonna be called root folder. That's still gonna extend fs item. Or we can call this, let's call this root folder, and we will have some more code duplication. Basically, it has these properties, And we can even be a bit of an asshole and say that name equals slash. So the name is a slash. This is a public property, so if somebody wants to change it, they can, but we're not gonna do that. So we're omitting a lot of things that might be needed in a real life scenario, which means that maybe the design is not the best, but since we will be, none of these things are exported, so they will only be used within this file, and we might need to take care of how we are using and why, because this means that we can change the name whenever we want to change it and things like that. That's not a good idea in general. For example, we can set the size, but for a file, there's just no way to change the size. So we're going to have a root folder that extends fn item. We're going to have a folder that extends fs item. And the folders always have a parent that is a folder or a root folder. Yeah. Right now, folder and root folder are not related, and that kind of irks me because they are essentially the same thing. But who knows? So we're going to create a new root folder, and it will have a constructor without anything, and we can do root dot. You can see we can change the name, we can get the size, and we can modify the children. For the root folder, it also has a children array, which is an empty array. And we have here one thing that's not very JavaScript-like, because JavaScript doesn't really like it when we have back references, circular references, because the root folder will have a reference to the child over here, and the child, which will be, for example, a folder. Actually, we can add this to the file as well. We can even add it here. Actually, I think this is a great idea for the name as well. Yep. So this means that the parent will automatically get set using the constructor. And why not, since we're going there, we can also have this and just call super inside it. And then we might want to remove this because we don't actually need it twice. So we have a root folder, and that root folder has children, and those children have parents, and that parent could be a root folder that also has children, and that's a circular reference. And that thing is kind of impossible to move to JSON. And since we are used to moving all our JavaScript objects to JSON with no problems, this is not really a common pattern in JavaScript. But this time I think that we could get some use out of it. So our input today is going to be a simple root folder. And folders are specific things that are naturally recursive. A folder is basically a tree, which means each time we have a folder, that folder can contain other folders, and the size of the folder is the sum of the size of its subfolders, and so on. So a lot of the definitions will be basically and totally recursive. So we're going to create a new root folder and return our root folder. And at the very least, our code looks happy. Let's see if it will actually build. And execute. It will. Right now, of course, it will return 0 because we're not actually doing anything significant, either with the input or after we're done parsing the input. So now we need to see. We have two situations. What we're gonna need to take care of is we need to gonna take care of something that is called current folder. Yeah, this is the folder where we will be doing our operations. So that means if we have a current folder, and that current folder will be initialized to root folder, and since we ended up writing that folder or root folder thingy a lot, I'm just gonna do this. I'm gonna rename the folder to a child folder. And then I will create a type called folder. And that's gonna be a child folder or a root folder. So now we can avoid all of these because the parent of a folder is a child folder is a folder, and the parent of a file is a folder, and the current folder is basically a folder. Yeah, we have to do the annotation here because otherwise it will just infer that the current folder is a root folder. But no, we want it to be any kind of folder. So now we need to process the lines. Again, it never learns this that I don't like I as the loop variable. I'm gonna use index. So we have our line. So we have two options here. We can have a command line, which can take three, let's call them options. One is ls, one is cd name, and one is cd dot dot. So we can separate those things. If line, this is somebody else's code that we'll see, maybe we will use something of that, but I wanted to start with the ls example first, as that's the first one we have. So if it exactly equals this, we can, what we need to do, run next lines until end or dollar or next command basically, and then we're gonna continue because we don't need anything else. We have if line is equal to that, then we need to say this, but the current folder is a folder, and the current folder could have a parent, but maybe it doesn't. Will this make it happy? No, it says I have no idea. But now we can basically say current folder as child folder. Can we do if Yeah, we're gonna do this. Yes. So the current folder cannot be the root folder. We cannot go up from the root folder. So basically, if we go up from the root folder, we will try to explode. If we explode, then it's okay. To be honest, most systems, if you try to go up from the root folder, will just say, yeah, going up and stay on the root folder. But I'm not sure if that was specified. That contains. And basically, no directory contains the current directory, and my WSL broke. Is this? No, this is broken as well. So, ignoring that, so then we can say what is the current folder here. It's a folder, and then we can do this cast kind of safely because we know that the current folder is a child folder. And otherwise, if the line starts with that, and now we're gonna use this because then we can take out the first 5 letters. It's a dollar space CD space, and everything after that is the name of our subfolder. If we are going to that folder is in, well, I'm not sure if that's what we need. We need to see whether we have that. So if current folder.children has the same name, if we have a child with that name, and actually I'm gonna do a find here. That is the child. I don't like using let, but in this case it's quite okay. When we want to make sure that we only have one item, we could of course do this with a ternary operator, but it's gonna be inefficient because we're gonna need to see if there is a child, and if there is, then use it. And right with this, I either get the correct child here or I don't. And if I don't, then we can create it and add it to the children. So we create a new child folder with that folder name and with this folder as the parent. And that's exactly the constructor of the child folder. And to the current folder's children, we add this one. Next, we don't need this. We just say, well, the current folder is the child, and we don't actually need to continue because we're gonna be done. Oh, what happens if we want to change into a file? For example, what happens? We have, for example, in the root, in this example, we have a directories that are called a, b.txt and c.dat and a direct and a. What happens if we do cd b.txt? Or here, if we just say cdg, that should be an error. So we need to take care of that as well. And that was code by TypeScript because of our structure that we built. So if child is an undefined, yeah, do that. If child is not a child folder, do this. And note that child right now is a child folder because we already checked that if it's not a child folder, then we're gonna throw, which means that if we go to this line, child will always be exactly a child folder. Yeah, and actually if we change, since a root folder and a child folder is that, we can have this inverted here, and then we don't need this cast here. Oh, we don't need this cast here because right now the current folder will always be a child folder. We have kinda ifs, a lot of ifs here. Let's see if this actually runs. Yeah, it returned. Now the bad thing, if for in part 1 we say console log inputs, just log our root folder to the console, which is not an uncommon thing to do. In JavaScript we are used to just logging entire objects on the console. Not so much in other languages, to be honest, because most other languages don't have such a versatile console log. And you can see that here a console log actually managed to do the job, but we have this and we have this. It detected that this is a reference. It added a reference to the root folder and says this is a circular reference to whatever, wherever star1 was. And then we have a children, which is also an array. And if we see from the input, the folder D, where is the CDD? Here, only has some files inside of it. It doesn't have any folders. And the folder A has a folder called E inside of it. So this should be, yeah, folders that all called E. Yeah, only a folder called E inside of it, which has some files. Yeah, this is a folder, this is a folder, this is a folder, this is a folder. So right now we have our structure basically, but we don't have any files managed, which is not ideal, not complete, but good enough. So we want to parse these lines now. What happens when we say ls? So when we say ls, is it possible to say ls on an empty folder? That part I don't know. So is it possible to have an empty folder? Let's see if we have somebody that we are calling ls. And we have a dollar right after it. Doesn't seem so. Seems that all the folders contain at least one file. But we said, as we started, we're gonna make no assumptions, not too many assumptions, and we're gonna throw errors if those assumptions are broken. Let's do that as well. So, no, we're not gonna do that. So, we have our current folder. So right now that means that we're gonna get the full contents of our current folder. And what happens if we redo ls in the single in a folder that already exists? That means that we should get the exact same result. But if we already have those children, why mess with them? So, one next thing we need to do is verify that we actually have some kind of output. So, if we are on the last page, yeah, let's have it like this. If we are on the we have a $ls command on the very last line of input, then that's an unexpected end of input because it means that we ls'd an empty folder for the end. And both here and here, that thing that just doesn't happen. Which means that we can increase the index. And this is the good thing about for loops. This is not a technique that is usually used when you are managing the index within the for loop, but it's definitely possible and definitely doable. So when we get to a for line and an ls line, what we're gonna do? So first time that we're gonna process, let's see, if we're processing this line, we're processing this line, we're going to the next for loop. If we process this line, we're not only gonna process this line, we're gonna process this line. And on the next for loop, it will go directly here. Because that actually makes sense. We are processing the output of the ls command. All the next lines until we get to the $sign is until we get to the $sign, we're fine. So while the index is less than the length of lines and the line does not start with a $sign, process a file. But when we're done processing the file, basically we ran over. We started processing on process this line, moved here, 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 and now we're here. And if we end the for loop, continue the for loop here, the for loop itself will increase the index and it will go here and it will skip this one. So once we're done processing, what we're gonna need to do is basically go backwards. I think because this will be tricky. I will need to see this to actually believe it. So how will the processing of a file turn out to be? If we have a file, yeah, that's the file line, and then we're gonna need to split it on a space. If we don't have two, yeah, I will definitely want to do that in file fillet file line, but I will add the file line as well. And a dollar here. Otherwise, the first name, no, this is wrong, actually. The file name is the second part. And now, if parts of 0 is strictly equal to the word dir, that means that we have a folder. And if we have a folder, Then we need to create a new child folder with that file name of the current folder. Else, that's the size, and the size is the first part. We need to create a new file with that file name, that size, and its parent in the current folder. And additionally, each time we set the current folder as the parent, we need to modify the current folder's children. Only one more thing. And at the very end, we will need to increase the index. One more thing. What happens if we do ls twice on a single folder? Because to be honest, this input and this input are exactly the same. We just typed in ls twice. We can type ls how many times we want. It's not what we are given to work with, but that's a truism, so to say. So that means that we need to avoid adding children if we already have that child. So if, yeah, that's not gonna help us because we're not listing the dot and two dots folder files, directories, so to say. That's common in Unix and DOS, but we will need to see if the current folder children we're gonna need to invert that. Actually, we have two specific cases here. Either we have just one ls, either this is our first ls for a folder, because the good thing about this is that we have a static folder structure. Anything this and this have to be exactly the same. Otherwise, it's not the same file system, which means we're gonna detect fairly early on when we're processing this that we have a duplicate, but then we don't know where this is. So if we detect a duplicate, we're basically gonna need to run ahead, and that might be a bit tricky, and that will involve writing more code. So I will take the coward's way out. This is not gonna be performant, as if we have this case, we're gonna look for A and find it and say, oh, we have A. Then look for B and find it and say, oh, we have B. And then look for C and so on and so forth. When we could have said, oh, you already have A, let's skip all this. Yeah, so it's not the most performant, but from what I've seen, the input is mostly deep and not wide. We don't have a folder with 10,000 files, but we will have folders that are nested 10 deep. So we will see here that if the current child has a child, actually I will invert this, every child has a name that's not the file name, then we can add the new child, otherwise we're not gonna add the new child. And if that works, add the file to the folder. Let's see what happens now. It actually said that we have in the root, we have 4 things. We have 4 things, and those are btxt, see that, with specific sizes. The sizes look correct. I guess parsing integers is a known thing, but I remember that I recommended adding a 10 here always and forgot to add that. And both the D child folder and the A child folder have some properties. Let's just say input.size. Let's see what the size is, and this should recursively trigger the calculation of all the sizes. And if we are correct, it should give us this number. 483, 811, 65. 483, 811, 65. So our size magic is doing its magic. So now we need to find all the directory with the total size of at most 100,000. So that's gonna be relatively easy. And we can do it recursively, but in this case, when we need to do something like this, I prefer a queue. Yeah, I'm gonna add the input inside the queue and I'm gonna have result, which is also gonna be a folder array, and that's gonna be an empty array. And I'm gonna say, well, the queue is not empty. This will trigger lots and lots and lots of recalculation of the size. So if I notice that things are getting slow, I can always change the implementation of this. Because that's the nice thing about properties. They have some implementation. And if I change it or tweak it or cache it or do something to it, it doesn't change the behavior of nothing, basically. It can just make it faster. So I can say const folder we're gonna need to get the first thing from the queue, and I'm gonna add an exclamation mark because otherwise this could be, oh, I guess this is fixed in some version of TypeScript, because right now, because we already checked that it's bigger than 0, shift will guarantee, I can guarantee that shift will return me a valid folder. And now I can say if folder.size is less than that much, no, that much, 100,000. Was it 100,000 or was it a million? It was 100,000. Then add it to the result. If it doesn't, if it's not, don't add it over the result. And now I can say for of each child of folder.children, if child is a child folder, it doesn't matter if it's a child folder. If the child is a folder, push it to the queue. And now the problem is that the class is a actually a JavaScript thingy. So I can say if something is an instance of a child folder, but the folder concept is just a TypeScript concept. So I cannot use it in my explicit code. For now, I will add it, leave it as a child folder to make sure that this actually works. But that will be a nice video from some other day that we can actually take a look at how to do a guard clause here. Because a guard clause is a TypeScript method that will enable me to do that kind of resolution that will help me in writing. So I can say that the child is whether it's a folder, any kind of folder. In this case, we have a workaround that is compatible with JavaScript. In many cases, we might not, because uh, if it wasn't for the size calculation, I would have modeled all of this with interfaces. But I didn't want to have an external size method. I wanted it to be an internal size method. So yeah, we did it with classes, just as an all the using all the concept of OOP. So after we have this, if this works, we're gonna have a result array which contains all the folders that have a size of less than, was it less than or equal? Total size of at most, which means less than or equal to 100,000, and then we need to push it. And then we just need to have a folder and get the size. No, we don't need to subtract the input size. Let's see what it says. Hopefully we will get the correct answer. 95,437. 95,437. Yeah, that's cool. Now let's get the huge input and see if this will run as well. And you can see that we spent 173 milliseconds processing the input because of all the loops and whatnot with the LSS and everything. And then the running time for part 1 was just 1 millisecond. And that included lots and lots and lots of calls to the size method. And we've been waiting for nothing because I forgot that the txt files are actually not watched by NodeMon, so it doesn't matter that I changed it, it didn't know that it was changed. So we received some answer that is in the neighborhood of 2 million. Let's see if that possibly could be our correct answer. If it is, great. If it's not, well, who cares if it's not, because it is. We have one more star on the seventh task. So now you're ready to choose a directory to delete. The total disk space available to the file system is that much. To run the update, you need an unused space of that much. You need to find a directory that you can delete that will free up enough space to run the update. The example about Atmos directory. Aha. So that is the total amount, this is the free amount. So that means we need this much amount, and we have the following directories. E and A are too small, D and slash are big enough, choose the smallest, D. Okay. Basically, we got kinda lucky. And to be honest, it was kind of obvious that for this task, the second part will be relatively easy, because the real task in this problem, in this day, is parsing the input. Once you parse the input successfully into a tree, you can ask me anything about the tree. So now for part 2, well, I will copy this because we're still gonna need to do something. And actually, to avoid doing a lot of recalculations and whatnots, because for example, we are calculating things at least twice here. On the other hand, 17 milliseconds, 206. We can bring this down a bit but this is not really effective regarding this, and everything that's under a second is, I'm fine with that. It could be optimized, but the first rule of the optimization is, do you need it? Does it make sense for you to optimize something that is fast enough? Because you can waste a lot of effort and a lot of money of optimizing something that nobody has a problem with. First rule of optimization is find where the problem is. And if you don't have a problem, then you don't have a problem to solve. You don't need to solve anything. So we have our results. So right now, instead of doing this, well, we need to just define some constants. We can say we need to calculate this value. So this is total. It's 70 million bytes or whatever. And we need this much. That's the root folder size is how much is used. And the free size is total minus used. And then we have how much we need to delete is from the needed, we need to subtract the free, and that is how much we need. So that means for this case, we will have just a sec, yeah. We will have used is 21 megabytes. We will have that there are, no, the used will be 48 megabytes, the free will be 22 megabytes, that's up to 70, and then the required are 30 minus 22 megabytes, and it turns out that we need to use something like 8, we need to free something like 8 megabytes. Okay. Actually, we don't need a rule, anything like this. We just need to see the minimum folder that is bigger than the required. And we can assume that the used will be, that the free will be less than the needed. Because otherwise we can just, if required is less than or equal to 0, then we don't have a problem. We can just say we don't need to delete anything. Or we can throw an error or whatever, what have you. But otherwise, we can say that the minimum is equal to the input size. Because that's the worst case scenario. That's the biggest thing that we can delete. Basically, we can delete everything. And if we delete everything, then we have enough free space. But the problem is that we need to find a folder that's just big enough. And the good thing is that we need to find one folder. A weird thing to be would be to find a set of folders which will be minimal as a whole. Because then we need to take care that, for example, deleting directory A in our case also deletes the directory E. because the content of this file is counted twice. So we might say that it's okay to delete directories A and E, but that will in total free this many bytes and not this many plus this many. Same goes for other things and other folders. So there will be some kind of creative algorithm needed basically to see which folders we want to delete and which folders will not. What is the optimal way to delete folders? But in this case, that's not what is needed. What the task asks us to do is basically find one folder that is whose size is bigger than our threshold, but otherwise minimal. So we can just say if folder size is bigger than our, oh, that was is bigger or equal to required, and it's less than the minimal, that you are the minimal. Return the minimum. Do we have the small input? Yep. So this should tell us that we need to return delete the folder called V. Yep. 249. Yeah, that's the one. We are deleting D. Let's change it to the huge thingy and restart the processing. It says that we need to delete this folder. Let's see if that is true. A folder of that size. And that's the right answer. So this is a great place to be. We finally have caught up. We only have the task 11 to solve, and I've taken a peek, as I said, and that's gonna be another fun thing to parse because we have some state machines that we're calling monkeys and that we're gonna need to parse and then simulate their behavior. And those behavior is very numeric based. So that's gonna be fun to program, well, fun to simulate. With this kind of problems, the tricky part is that you might get some small simulation errors, but once you get the simulation going, it's easy peasy. So that has been our task number 7. We are 2 stars closer to the having a full ASCII whatever this is. Don't forget to like and subscribe, and thank you for watching until the end.